Hi everybody, Professor H here. Today in this video, we're going to talk about the nervous system. The nervous system is the way that the body communicates. This first screen just kind of gives us a little bit of an outline of what we're going to talk about in this video. The two main body communication systems, the nervous system, and we're going to talk a little bit about the endocrine system, which is another way that the body uses for communication, only it's a bit of a slower method, whereas use of neurotransmitters in the nervous system is a very fast way to communicate. We're going to start off with these terms right here. The nervous system, which is the chief means of communication within the body. It is divided into two main parts, the central nervous system, which comprises the brain and the spinal cord, and the peripheral nervous system, which is further divided into the somatic nervous system and the autonomic nervous system. The somatic nervous system is mainly responsible for things that are not voluntary. So if I want to walk across the room, raise my arms up, do something like that, that has to do with my somatic nervous system. So those are voluntary movements, whereas the autonomic nervous system has to do with automatic movements, things that are not voluntary, involuntary systems. That particular system, the autonomic nervous system, is broken down into two smaller systems, the sympathetic and the parasympathetic nervous system. And we'll get into more detail about these in just a minute. Okay, I like to use this little breakdown to help explain the nervous system. So this is broke down really nice for you in this graph. We start off up here with our nervous system. Our nervous system, as I mentioned in the last slide, is divided into two main components. The first component is the central nervous system, which is the CNS. You'll see it marked down as CNS in certain stuff, in certain literature. This particular nervous system is only comprised of our brain and our spinal cord. And you'll see here in dark gray, the brain and the spinal cord. That is the central nervous system. The peripheral nervous system is basically everything that comes out from the spinal cord. So from the spinal cord outward or from the toes inward, that is the peripheral nervous system. This system, like I mentioned earlier, is divided into two other systems. We have the autonomic and the somatic. The autonomic has to do with those involuntary movements or involuntary things. For example, some reflexes can be having to do with our spinal cord, because actually our spinal cord can help us to have a reflexive response even without going to the brain. So I'll back up for a second and talk about that. Inside of our spinal column, we have our nerves that are coming in. Say I was going to touch a hot pan with my hand. I have sensory neurons inside my fingers, so that can detect the heat. So when I put my hand down on a pan that's really hot, like maybe I'm touching the cast iron accidentally with my hand, my arm is going to automatically draw that hand away very, very quickly to minimize the amount of damage to the hand. This is done by these sensory neurons in my hand sending a signal up to my spinal cord, and the spinal cord, through use of an interneuron, sending the signal right back down to my arm to jerk my hand away. In this circumstance, this response does not have to be sent all the way up to the brain for processing and then back down to the arm. That would take more time, and that would give an opportunity to have more damage to the body. So simple reflexes of that sort don't even involve the brain. They involve the sensory neurons going up to the spinal cord and an immediate response being sent back to the body part to have the reflex occur. So that's kind of fascinating and interesting that your brain isn't even involved in that. But that's something that your spinal cord could do. Your autonomic nervous system over here on the other side has its own way of responding involuntarily to things without really having the brain too much involved there. It is not like an automatic It is not like a true reflex, but some of these things happen very quickly and very automatically. The autonomic nervous system is broken down into the sympathetic and the parasympathetic. And then on this side, once again, we have the somatic, which is the voluntary system. So the somatic system here is like if I want to wave my arm or get up out of the chair, my somatic nervous system is dealing with that. Over here with the sympathetic and the parasympathetic systems, which are part of the autonomic nervous system, I'll give you a bit of an example of how they work. The sympathetic system will prepare you when you're under stress and prepare you with that fight or flight response that you need to respond to danger. Your parasympathetic system, on the other hand, is going to bring your system back to homeostasis. So after the danger has passed, you're going to have your parasympathetic system bring everything back to normal. So an example is I'm just tootling through the woods. Okay, so I'm walking through the woods, minding my own business, whistling, it's a nice day, cruising along. I come around the corner on a trail and suddenly I see a bear up ahead on the trail, a very large bear. Suddenly my sympathetic nervous system goes into action. My pupils will dilate, my capillaries in my lungs are going to expand, my heart rate is going to increase, my respiration is going to increase, my digestion is going to slow down. And you know how you see in the movies how the scared person wets themselves? That's because the bladder also relaxes. So all of these things occur instantaneously. So these things happen right away. And then I am ready to run for my life or fight a bear, whichever the case may be. That's what my sympathetic nervous system does for me. It kind of has sympathy for me in this situation. That's how I remember it. It has sympathy for me, and it prepares me for that fight or flight response. So a few minutes later, or a few seconds later, I get a better look at the bear, and I realize it's just a rock. And I don't have my glasses, so I thought it was a bear. It's really actually just a rock. At that point, I will take a couple deep breaths, and my parasympathetic nervous system is going to give me a couple little pats on the back and say, there, it's okay. And all of my systems are going to return back to normal. So my pupils are going to go back to normal. My heart rate will decrease. My respiration is going to decrease. Everything's going to start working again. So this is the little graphic that's going to show what the parasympathetic and sympathetic nervous system do. So when I see the bear, as I mentioned, pupils are dilating. Oh, it inhibits salivation. Forgot that one. Increases your heart rate, dilates your bronchi, which is in your lungs, opens everything up to receive more oxygen and be able to run fast or have air for fighting. It inhibits digestion and inhibits the contraction of the bladder. And then on this side, the parasympathetic brings it all back to normal again. So it just puts everything back to where you were ahead of time, back to homeostasis. All right. A couple other notes about the brain and the spinal cord. Once again, this was the central nervous system. The brain is comprised of billions of interconnected neurons and glia. We're going to talk about those in the next video. We're going to talk about the structures of the neuron, what the glia does, and about the action potential. But we're going to go into all of that next video. The brain is bilateral, meaning that it has two sides. We'll also cover that. Actually, in 2 videos from now, we'll cover that when we talk about the different brain structures that we're interested in for this introductory psychology course. It can be separated into distinct lobes, but all areas interact with one another. You've probably all heard by now that you have 4 different lobes or areas of the brain. And there are certain things that each lobe may have specialized areas in those lobes. However, the entire brain is integrated together and works together. The spinal cord, we're not going to go into a bunch of detail about this, but it delivers messages to and from the brain. So when I touch the table, I can tell, okay, it's cold, it's the table. That signal is going up to my spinal cord, sent up through an area of my brain called the thalamus, and then processed from there. Once again, the spinal cord has its own system of reflexes, which I already talked about. And the top of the spinal cord merges with the brain stem, and the bottom ends just below the ribs. So anyway, we'll go over all that. We'll go over all that in our other section there. Sensory nerves bring messages in and up to the brain. Motor nerves send messages out to the muscles and organs. In moments of survival, the automatic reflexes allow motor command to be inhibited without sending signals from sensory nerves to the brain first, allowing for very quick reactions. So when we are instantly in need of our body to adjust so that we can protect ourselves, that's when it automatically kicks in. That autonomic nervous system takes place and just kicks into gear and gets us ready. Or in certain situations, it might just be our reflex, a simpler reflex, where our spinal cord is doing the work there, depending on the situation. All right, as I mentioned before, the endocrine system is another way that the body communicates messages throughout the body. It exerts its functions through hormones, and hormones are chemicals that affect physical or physiological processes, or both. The pituitary gland is something we call the master gland because it has a big impact on the rest of the other glands. It's regulated by a brain structure called the hypothalamus. Other endocrine glands, such as the adrenal glands, secrete hormones that regulate the excretion of minerals and the body's response to stress. So when I saw the bear and went, that is when my adrenal glands secreted a bunch of epinephrine into my system. Epinephrine is adrenaline. It's the same thing, and norepinephrine. So it's secreting these things into my bloodstream and secreting these things. Yeah, some hormones are going into my bloodstream, such as cortisol. That's something that's released at that time as well. And these other neurotransmitters are being released in order for me to have that quick response. Then we have the gonads, which are the testes and ovaries. And we all know that those can have quite an effect in our teen years, especially. Okay, so on this image, this just kind of gives you a quick look at some major glands. The thalamus is a brain area, a midbrain structure that helps all the input that we're getting from our sensory neurons, for example, in our mouth, in our skin, our fingertips, any information that we get that's sensory will go in and it will process through this thalamus and then be sent to the correct brain area to process that information. For example, if it's visual stimuli and I'm looking at something, like I am looking at this picture right now, then the information that comes in from my eyes, which are sensory organs, goes into the thalamus here and then is directed back here to the occipital lobe where my visual processing takes place. So the thalamus is a really important relay center in the brain. The glands that we're showing here, and the hypothalamus is another important structure, brain structure. And we have the hypothalamus is really important for homeostasis. For example, the hypothalamus can tell me when I'm hungry, when I'm not hungry. It works with the hormones and the things like in my gut that are telling me those things. But the brain processing part is in the hypothalamus. It helps regulate us and bring us back to homeostasis. The pituitary gland this is the one we're calling the master gland. And it's a very interesting gland because most things that we have in our brain, we have the same thing on the right half as we do on the left half. So both hemispheres mirror each other, and we have the same structures on both sides of the brain, with the exception of this pituitary gland. This pituitary gland just kind of dangles down here. It's actually up kind of behind where our sinuses are, back behind there. And it is the one that it regulates a lot of the other glands. It's a really important gland. We have the pineal gland. The pineal gland is really important for arousal. For example, it secretes cortisol I'm so sorry. It secretes melatonin. Oof, I need some sleep myself, which helps us with sleep. Melatonin is something that helps us to regulate our sleep-wake cycles. And also, this pituitary gland down here releases growth hormones. So when people are growing or things are happening in our body and we need to have some changes going on, growth hormone is secreted, but it's mainly secreted at night, and it is somewhat regulated by the pineal gland and by the secretion of the melatonin, which is kind of interesting. There's a relationship there. Okay, so those are some major glands. This picture here is also about some major glands in the body. So this just, if you're interested, this one will just kind of show you where the different glands are. All right, our next video, we're going to talk about neuronal activity, which means we're going to go over the structure of the neuron. We're going to go over glial cells and how they work, and talk about how the cells communicate with each other, how neurons communicate with one another. And I guess that should probably do it for this video. So if you guys have any questions, as usual, feel free to reach out to me through email, or you can even put a note on the videos, but it's much better to reach out to me through email. I do look at the comments, but don't really have too many comments. Not really that popular for some odd reason. But anyway, I hope that I'm not doing this to be popular. I'm doing this in the hopes that these videos will help you to understand our content for the course better. That being said, I am done with this video, and I look forward to seeing you guys in the next one. Have a really nice day. Bye-bye.